Well, hello again. Multimedia Science is back, this time with a rotational motion lecture aid. This is used by a teacher who wants to go through the derivation of equations and show some examples of exactly how rotational motion behaves. So let's go through very quickly here. This shows the difference between translational and rotational motion. This is a step-by-step definition of what a radian is. And what the angle theta stands for. Then we go through how we convert from degrees to radians. So you can see we're going through the equations for rotational motion. And then we have a demonstration where we can set the period. And you can see very clearly how the period, frequency, and angular velocity are all related to one another. And we can start and pause, start and pause, and see exactly what it means to change these variables. We can also add another circle to show that it doesn't matter how big the circle is, that these variables behave the same for any size circle. Of course, then you can reset. You can change the variables, start it again, and you can see how that change in period will change the rotational motion. Now we'll go talking about the linear velocity, derivation. That leads us to the equation for linear velocity. Another demonstration. You can choose the period, you can choose the radius, and when you start, you can see how these variables affect the rotational motion. And again, see the relationship between the variables in rotational motion. Now we have the definition for angular acceleration. Same demonstration, only now we can change the angular acceleration. Again, we can see how the variables change. Of course, now you can see there's a rotational acceleration going on. We can show again that if you have two circles, that the angular acceleration is the same for any size circle. And you can reset, and let's really rev this up. You can see how quickly it starts to move. And the equation for tangential acceleration. And the fact that there's sort of a one-to-one correspondence between the linear variables and the angular variables, leading us to similar equations between the two ways of looking at motion. So that's rotational motion. If you're interested in getting a copy of Rotational Motion by Multimedia Science, you can go to Teachers Pay Teachers at this URL. This is a Multimedia Science store, and type in Rotational Motion software. Hope you enjoyed this video. Take care.